I love microservices, but let's say for the wrong reasons. Please don't think about coupling as something necessarily bad that you need to avoid. No. Let's think about coupling as it was defined initially, and that term dates back all the way to Latin. There, I mentioned that microservices were the second coming of domain driven design. Right now, it looks like AI is actually the third coming of domain driven design.
The episode is brought to you by icepanel, a collaborative diagramming and modeling tool for architects. If you are struggling with scattered diagrams, no single source of truth, or consistent way to talk about your systems, I got you covered. Icepanel lets you model how your system works, from business views to technical details. Zoom in multiple levels to show the apps, stores, and components that make up your system. One of my favorite features is flows, which completely change how I explain architecture. Instead of static sequence diagram, I can show animated flows that people instantly understand. icepanel make it easy to maintain your diagrams. Update once and everything syncs. No more managing duplicate objects across different diagrams. And one last cool thing is icepanel's APIs and MCP server, which lets you connect your data to your favorite LLM. Try out at icepanel.io/Luca and get free 2-week trial. Hi, everyone, and welcome to a new episode of Dear Architects podcast. Today, I'm extremely excited to have this guest with me. He definitely influenced deeply the software architecture space with his books around coupling, modularity, and domain-driven design specifically. The last one is definitely one of my favorite. It's something that I highly recommend to everyone because learning domain-driven design is well written. It's not too long as well, but it goes in depth about several topics. So highly encourage you to read it. Probably by now you understood that we are going to have Vlad Kononov here. And Vlad for me is, let's say, also a person that I would call a friend because we met several times in conferences, we exchanged ideas, we chat sometimes online. So it's definitely a person that is great to learn from. And he has like many strong opinions. We love strong opinions here in Dear Architects. And we are going to touch in this episode quite a lot of ground. We are going to talk about modularity, coupling, domain-driven design, and everything in between. Obviously, with an aspect of an architect and with the ideas from Vlad that are definitely groundbreaking. So without further ado, Vlad, welcome to the episode.
Thank you so much, Luca. It's such an honor for me to be here, one of the first episodes of your podcast. And yeah, let's do some geeking out.
Absolutely. So before we start, as every time, I like that you share a bit of yourself, a bit of your background, even stuff that you like apart from doing software architecture. At least people start to know you a little bit more.
Wow. So you are starting with tough questions, aren't you? I see. Okay. So I love sim racing and I'm so bad at it. It's like embarrassingly bad, but at the same time, I enjoy it for some reason.
That's a good starting point. So let's start with the diving inside the episode, right? So in balancing coupling in software design, you talk about modularity, but you have like a very interesting concept regarding a spectrum, right? So it's not just, oh, modularity is this definition. I would like that you share with us what is all about and how to apply this mindset inside our architecture as well as software design.
Yeah. So, all DDD people know the importance of modeling. Like, if you want to build a system that will stand the test of time, that will be able to evolve on par with the business, you need to invest in modeling. You need a model that reflects that business so that when the business changes, the model could be evolved as well. And yet, at the same time, at least in my opinion, we don't really pay enough attention to the models of software engineering that we ourselves are using when designing software. And of course, I'm talking about concepts that we kind of understand intuitively. We think that we do, but the vast majority of people still have hard time explaining what these things are. And That's modularity, that's complexity, and two of my favorites, coupling and cohesion. We usually say that coupling is bad, but cohesion is good. How to achieve cohesion, how to avoid coupling? Well, that depends what vendor you are talking to. You will get different answers. Now, because of that, I invested lots and lots of time in that research that led me to writing the book Balancing Coupling in Software Design, in which I try to answer those questions like what exactly modularity is, what is complexity, what is the relationship between the two, and the same about coupling and cohesion. What is coupling and how it relates to cohesion and how we can manage it. How can we achieve whatever we want in the future and not get, accidental design decisions. So speaking about spectrum, for me, modularity is, first of all, it should be defined. We need to define what is modularity. If you're looking at Wikipedia and the traditional sources, you will see that modularity is about breaking things apart into small chunks of something so that you can combine them, recombine them, and reuse them. Of course, that's like number one goal. Now, do we really need reuse? I don't think so. Does that mean that we don't need modularity? Probably not. So I see modularity as the ability of a system, the design of a system, to support not only the current goals of that system, what is the functionality that it has to implement, but it should also support future changes and future needs of that system. Now, doesn't mean that you need to implement all those future requirements, no, but the system should be decomposed into components in such a way that will allow us to make those future changes as easy as possible. It should be ready for those change vectors, those reasonable change vectors that the business might need. Now, how do you achieve that? Well, that's where we need to think about coupling not as something necessarily bad, something that we should avoid, like run away from coupling and strive for cohesion. No, we need to understand how coupling works, understand the dimensions, the three dimensions. It affects your system design both in short and long terms. And then we'll be able to decide whether that a combination of dimensions is going to work towards modularity or, on the other hand, towards complexity. So the spectrum is the combination of those coupling forces. Different combinations will result in different results, and it all depends on business needs. That model, was deeply affected by domain-driven design. So actually, in some places, it favors complexity instead of modularity. That might sound controversial, but yeah, again, learning from the best from domain-driven design.
I hope when you talk about complexity, you think about essential complexity more than accidental complexity. Just to name a few other resources that are really great, like No Silver Bullet white paper. So you often talk about coupling that is inevitable, right? I listen to your talks and obviously read some of your books, and I would like to understand more. What deserves to be coupled and what shouldn't be coupled?
Yeah, so to answer that question, we need to rethink our mental model of what coupling is. And for the next 1 hour or whatever time we will need, please don't think about coupling as something necessarily bad that you need to avoid. No. Let's think about coupling as it was defined initially. And that term dates back all the way to Latin. It predates software engineering by many, many years. And the meaning of that term is connected, fastened together or connected. So whenever you have two pieces of something connected, they're coupled. Now, if you decouple them, they're not going to be connected. If you're looking at a system is a set of interconnected components working together towards a goal. If you decouple them, you will get a bunch of components, but they won't be able to work together. in order to work together, they need to be connected. They need to be coupled. So coupling is it's not avoidable. Now, once we start thinking about coupling in that way, as first class citizen of our software design or system design, then decoupling, or like people used to say, fully decoupled components of a system, suddenly those definitions make no sense. And suddenly you understand that, okay, it's not about disconnecting things, it's about keeping them connected. They need to work together, but you need to look at how they are connected. What happens across those connections? Like if you're looking at a diagram, you have two components. Components can be anything, microservices, objects, even methods, doesn't matter. And we have that line that defines, that describes that connection. Well, we need to think about what that line represents, how it was designed, like what is the knowledge that goes across that line from one component to another. And once we start thinking about it that way, then suddenly cohesion makes way more sense. It becomes just coupling designed in the right way. That's the essence of cohesion. It's just integration that is designed in a way that increases modularity of a system.
Yeah, I think the interesting part of what you described is something that I often, let's say, highlight to people, that the coupling is not necessarily a bad thing. Very often, you do intentional coupling because one of the heuristic that usually I use a lot is rate of changes. So if I see that the rate of change is extremely low, like, I don't know, once or less in a year, then coupling doesn't hurt. I think is a mental model that I apply several times and have seen very successfully implemented in distributed systems. Therefore, when I'm thinking about how micro is a microservice, and we're going that direction now, I always think about, okay, so what is the rate of change of this chunk? Because if is a part that doesn't change very often, I can stay more coarse grain without having a direct impact on the performance of teams, or I don't need to reduce too many external dependencies. While on the other side of the spectrum, for me, when I think about rate of change on let's say an area that maybe is a core part of the system, thinking about domain-driven design, it's usually I need to be more clear on boundaries. I need to think more thoroughly how and when to split up my services, because that is for sure something that will be iterated over and over again, and I need to create a paved path to reach fast flow as soon as possible. That's usually one thing, the one mental model that I usually have when I'm dealing with the distributed system. And talking about distributed systems, so I would like to understand. You have a lot of experience in microservices and distributed system. I remember one of your first talk. You were in, if I remember well, was in London. I was speaker as well in that conference. I met you there, and we were talking about probably 6-7 years ago, where you were talking about your approach of modularizing through domain-driven design. That was a super interesting talk. For me, it was like quite refreshing seeing a proper application on domain-driven design in a real project. So that was great. So I wonder, and I presume also our listeners are wondering by now, many companies, they embrace microservices for the sake of embracing microservices, or better, they think that with microservices, all their challenges will fade out magically because the architecture is decoupled or is modularized, and therefore everything will work straight away. But very often, these companies are failing because they take into account only the architectural aspect. They don't change anything else around that. So I wonder, what is your take in this kind of situation, where at the end, what I hear several times in conferences and not is, oh, the problem is microservices are evil or monolith are evil. Why for me is just a way to let's say represent certain intentions inside a social technical system.
Yeah, so I love microservices, but let's say for the wrong reasons. I love microservices because that architectural style gave such a boost to domain-driven design. That was the second coming of domain-driven design because of microservices. And then, when all that hype started, I jumped on the bandwagon and I listened to all the thought leaders that share their success stories of applying microservices and how everything is decoupled, everything is evolvable, scalable, changeable, whatever, able. And I decided, yeah, I'll listen to them and I will just copy whatever they're doing. And I ended up with such a huge distributed monolith, like the complete opposite of what I was striving for. And that led me to start researching the topic of coupling. So yeah, I'm very grateful to microservices for forcing me to go into that direction. I just wanted to understand, like, what 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 had I did wrong there. That was the intent. Yeah, but microservices as a concept, well, it takes us back to that ineffective model of coupling, cohesion, and software design. Because, well, if you're looking at the essence, what people were talking back then, it was okay. So you have a monolith. That was everyone was doing back then. So you have that monolith. Let's split it apart. Let's make it modular by splitting it into small chunks. Now, how small? What is small? What should you measure when you're splitting them? Nobody said that. There were some crazy ideas like it should be easier to rewrite a microservice than to modify it, or that a microservice should be no more than X lines of code, stuff like that. And yeah, so people follow those suggestions, decompose their systems into those small blocks, and in the terminology of complexity, they exchanged the local complexity of a single component they were working on. They exchange it in favor of global complexity. Well, now you have all those poor integration of interactions between components, but they are no longer in one code base, but spread across many code bases. And if you need to make a change, well, good luck to you to coordinate those changes. And that's the classical distributed monolith. Yeah. So, and if I take it to the language of balanced coupling, well, when you have, let's say, I don't want to say monolith because monolith can be well designed. It can be modular. It can be way better than the majority of microservices based projects. Let's say if you have an old fashioned big ball of mud in one code base and you naively decompose it into components, what you're doing is you're increasing the distance, the physical distance between the components of your code base. Previously, they were in one code base. Now they spread across multiple repositories and multiple teams, components, etc. So you're increasing that physical distance, but you're not fixing the inefficient flow of knowledge between them. So now, whenever a piece of, let's say that you have a component and it shares lots of knowledge, maybe it shares the model of the business domain it uses internally, maybe it shares some functional requirements that are implemented in both couple components. And whenever that piece of knowledge changes, well, that change has to be reflected in both components. Now that you have longer distance, guess what? Coordinating that change is going to be orders of magnitude harder, both to implement, to test, and to deploy, because now you have to deploy two, and I put air quotes here, independently deployable components. That what microservices promised back then. You have to deploy them simultaneously.
And that's the real challenge, right? So I believe that is a clear signal that it's time for me to, or for a company to go back into the whiteboard and start to rethink what was designed. If the fine granularity was something helpful, or probably we screwed up the boundaries. And therefore we need to review that. And in fact, I would say this is definitely one of the signals in my opinion, when you need to constantly coordinate the deployment, or you have too many external dependencies in distributed systems, that requires, let's say, going back to whiteboarding and see, okay, let's take a step back. Why we arrived to this? Because maybe before was working and now not anymore. But do you think that there are other signals that could help people to rethink if the boundaries of their modular monolith, or even in a monolith inside different packages, are screaming a redesign?
Yeah, so the most important signal was given to us by evolution, and that's pain. Pain is very important. When you feel pain, you know, okay, something needs attention, I need to fix it. Now, architectural pain is a thing as well. Well, you're working on a big ball of mud, anything you want to do there is painful. Whenever you feel that pain, that's a signal that, in the language of balanced coupling, there is some inefficient flow of knowledge across the system that needs to be fixed. Now, the problem with people is that sometimes when we experience pain way too many times, we start to ignore it. And that happens way too often in software engineering. People just don't notice pains, that they're doing something inefficiently. And when you point them towards, something is wrong here, you're going through pain, you can improve it. But the answer is going to be, well, that's how things are being done here for many years. Like, why change?
Yeah, that's a very common thing. When I hear, "Oh, we always have done in this way," that's a clear red flag that something must change ASAP. Otherwise, it's not going to work properly inside the social technical system. I was wondering, considering we were talking about, let's say, designing and modeling boundaries, etc. Um, why do you think companies are, let's say, I cannot say struggling in designing, but struggling to carving out the right amount of time to invest, because for me, is an investment, is not, let's say, a waste of time, on gathering people and trying to design proper boundaries, as long as the understanding the new features that they need to implement or migration that they need to make. It seems to me that very often there is this friction inside the inside companies, where they think that, okay, we start with a bit of design, and then that is lost, because over time, because we have to deliver new features, we need to deliver a new chunk, because the C-suite wants something, let's say, new. I believe that honestly slows down the output and the outcomes more than accelerating. What do you think about that?
Yeah, that's the unfortunate reality of many companies. And, there can be different reasons for that. Um, like Leo Tolstoy said that unhappy families are unhappy in different ways. So I can give you a few examples like why that happened in different companies. One of them, it was business priorities. We need time to market. Our competitors are here. We need to be first, and we don't care. We'll just do something that works. We'll rewrite it later on. Is it going to be rewritten later on? Come on, never. Sometimes it's purely, lack of skills. In my opinion, domain-driven design is the way to design boundaries correctly, whether you are working at a higher level of abstraction like services, or lower level of abstraction when you have to implement how your business entities are going to be modeled and how they will work with each other. But domain-driven design, unfortunately, got this bad reputation of being hard, and people are afraid of it. And to this day, sometimes when I'm consulting a company, I will try to avoid using bounded context and aggregates, because people might get shocked just by hearing those terms. I will just say, let's say, something overloaded like service instead of bounded context, and then use all the properties of a bounded context, as a driving force for designing service boundaries. and it will work better. Yeah. So skills is an issue in many companies as well, and it's it's really unfortunate that many people are still afraid of domain-driven design.
I think in your book that, to be honest, for me was a nice refresh because I read the red book from Vernon and the blue book as well back in the days. I think your book was refreshing on domain-driven design because you cut a lot of noise and you went straight to the point on many topics. In fact, your book is not, let's say, a huge book of 500 pages, but you have everything that you need in order to deeply understand what to do and what are the next step, and also some let's say clear mechanisms for starting to implement, let's say, the day after that you read the chapter, like when you were talking about even storming, for instance. I believe that I agree. Sometimes domain-driven design is, let's say, or either underestimated or feared. But in both scenarios, I think you need to have a pragmatic approach also in that, right? So very often there are purists that they think, okay, we need to do everything in domain-driven design, from writing the last line of code to design, modeling, whatever. While sometimes you can have also let's say a mixed approach where you have like a more pragmatic one where you use the techniques that you need for modeling, for understanding how, let's say, the boundaries are, let's say, communicating together, how often those boundaries are chatting with each other, if the structure is properly, and also understanding how small is a boundary, or how is the connection between boundaries, and so on and so forth. I think domain-driven design has a lot of merit on several areas, especially the one that it doesn't have to be, let's say, end-to-end domain-driven design. You can still use your own practices for developing and your beliefs, or maybe, let's say, evolving over times. No one is stopping you to do that. But I think there is a lot of value on the initial part. On I need to introduce a new features, for instance, in a complex system, despite this monolith or distributed system, doesn't matter. Let me use a bit of, let's say, domain-driven design or modeling or whatever is the technique that works better in order to achieve that. What do you think about, let's say, having only some chunks of domain-driven design, especially on the beginning or on the modeling side?
I agree that that's the way. I also think that's the only way, because let's be honest, like, what, as a software engineer, what is the percentage of projects are going to be greenfield projects that you will work on? Well, hopefully not a large number, because otherwise, well, you have to explain why they never turn to be brownfield projects. So the vast majority of our work is working on existing code bases, and that's the hard part. When you design a new system from scratch, well, you have many options. You have freedom to make design decisions that you want. When you have inherited a code base that was maintained by many different people that are not working in the company anymore, well, that's where the real challenge is, and that's where the help of domain-driven design is really needed. But let's be honest, it's not possible to do a big rewrite and make that whole system designed following domain-driven design. That's never going to happen. So you have to identify, again, the pain points. What is the most painful aspects of that design, and fix them by applying those aspects of domain-driven design that are specifically targeted for those areas, for those pain points. And yeah, in my opinion, if you look at domain-driven design as a whole, I would say that the main value that you can get from domain-driven design comes from strategic domain-driven design. I would say, let's drop technical domain-driven design. Aggregates, domain models, event sourcing, that stuff is cool, but if you ignore strategic aspects of DDD and you invest heavily in aggregates, well, you will get a big ball of mud if you're working on a large system. On the other hand, if you invest in bounded context, in ubiquitous language, in identifying subdomains, but you will use, let's say, active records all over the place. Well, still your code might not be, shiny aggregate design, but it will work and it will be way more evolvable in the future compared to the first option. And yeah, as you mentioned, my book is, first of all, it's white belt book. It's for people that are new to domain-driven design, and if you want to learn about that methodology, well, that's the first book you will read. I'd say it provides 80% of value and 20% of content, so it's way shorter. Actually, this week I got an email asking why I haven't included factories and repositories in my book, and I say, okay, factories you can read about it in other books. It's not domain-driven design. Let's focus on the essence of domain-driven design.
Yeah, absolutely. I really like the approach. I basically read it in 2 weeks or 3 weeks top because it was very well structured. And then in talking about the domain driven design on the strategic side, that is exactly where I wanted to land. So tell me, let's assume, for instance, let's try to do this role play. Sorry. So let's assume that you are in consulting with a new company, and they tell you, listen, we have this challenge. We need to add this feature that will span across different parts of the system. Can you share with us the mental model that you will apply to start digging into how can I squeeze in an existing system a new feature? Because very often when you read books, when you let's say see talks, it's always I don't know. Oh yeah, we're starting from scratch, and this is what we have done, and it seems awesome. But not many people are talking about brownfield projects. So I have already a project. I need to expand it or add new things or changing something. And I would like to consider your experience, that if you can walk us through on your thought process. So what are, I don't know, the questions that you're going to ask to the company, or what are the techniques or mechanisms that you're going to apply in order to extrapolate information, stuff like that. Hold on. It's Jacob from Ice Panel. Hello.
Hey Luca, how's it going? Sorry to drop in like this on you. I was just out snowboarding and I was thinking about your listeners who are all wrangling diagrams and documentation instead of improving and upgrading their systems. It's why we built Ice Panel. It's for architects who are fed up of tens or hundreds of diagrams that disagree. They don't have a shared language between business and engineering, and their diagrams are rotting the second that they create them. In Ice Panel, you model your system once. You can go from a high-level business context down to the containers. When you make changes, which is inevitable, you update it once, and it'll sync across all of the views that you've created. When you're explaining a user journey or how data flows through your system, you don't just wiggle your mouse on boxes during a presentation. You can actually create step-by-step guides to explain how things work so that everyone's on the same page. Anyway, I'll let you get back to the podcast, and I'm going to go back to snowboarding. We'll speak real soon. Stay chill, Luca.
What a crazy guy, this Jacob. Where were we?
Yeah, so if I never worked on that project, then I will start from the business domain, like domain-driven design tells us to. I will start by asking questions about what that system is supposed to do, how it's supposed to serve the business, and from there try to identify its core subdomains. What is the core business? Why that system is more, why it's strategically important to the business, and why it's better than what competitors are offering, so that I could identify the subdomains that are at play there. And of course, all this time, try to see how that new functionality that needs to be added to the system is going to be reflected in each one of the areas of those in those subdomains where some integrations are needed. Now, if it's typical brownfield project, then usually in vast majority of cases, there will be different opinions about what the system does and how it is doing that. So then you can call an event storming session and start synchronizing the knowledge of different stakeholders people that have conflicting opinions, and build that shared understanding of what happens there and why it happens there. Now, once let's say that we achieved that better understanding of the business, of business requirements, of business functionality that is currently implemented in the system, well, we can ask two questions. First is, can we just go ahead and implement that new functionality because the design is okay, it supports that future goal? If yes, awesome. Let's go ahead and identify the module, the component of the system that needs to be modified, and do it. Now, real life, that's not going to happen. Usually some refactoring will be needed, to make the change easier. And then, actually at this stage, I prefer to use balanced coupling model and start identifying those coarse-grained components of the system, let's say services, or I prefer not to call them bounded context if that system was not designed in DDD way from the get-go. So let's say coarse-grained components, how they're interacting, and by that I mean not what is the information or what is the data that being passed across their boundaries, but what is the knowledge that being shared across their boundaries. What do they know about each other? Do they know only about the integration contracts, or they have some intricate details about, hey, we have two components using the same model of the business domain. Now we need to change that model because of that new functionality. Well, we have to change them together. Problem. Same goes for functional requirements. There might be strongly interrelated use cases implemented in different components. And in the language of domain-driven design, those are use cases that belong to the same subdomain, but somebody decided to split them and decompose them into different services. So then again, if that's the situation, we have to address it, because otherwise making a change that affects that subdomain is going to be hard. So let's think about how can we improve that? Can we concentrate that interrelated knowledge in one component? If so, what that component is going to be? If not, maybe it makes sense to just merge those two services into a single code base, work on it, and then decompose it later on in the future when we have more confidence in that design. Yeah, so it's really hard to answer that question in a few minutes, but that's the mental model. Start from business, then understand what is the design at this point of time. If there are inconsistencies in understanding, then iron them out using event storming, and then lower level design decisions, like what is the knowledge that's being shared and how it affects our new functionality.
Yeah, I double down in your answer because it's basically very similar to what I'm doing. But obviously, in everything that you described, there is a lot of collaboration. There are a lot of communication as well. And there is a lot of design, if you want, or reasoning. How do you think this will evolve in this era of AI, where AI is basically talking about context engineering and spec-driven development, and I think it's very interesting to see how we think today about designing a system and modeling, etc. And on the other side, we see a decentralization to a certain extent about decision making, where we tend to, let's say, decentralize more towards teams that I'm not against, quite the opposite, I'm in favor of. But I think there is still the need of a sort of enablement team that helps reasoning about these things or facilitating these kind of practices that are, I think, is still valid. But I would like to hear your take on this, where AI is basically shaping a new way of building software. So where domain-driven design fits in this new world, and the practices and the mental model you describe is invalidated or still valid and can be used tomorrow.
Yeah, that's a very, very hard question to answer, because to answer that, I have to make predictions about the future. And if you were to ask me 5 years ago about, the situation we are in right now, I would have never been able to predict it. Never, like, not a chance. So, yeah, I don't know what the future will bring us, but I can only speculate based on today. And earlier I mentioned that microservices were the second coming of domain-driven design. Right now it looks like AI is actually the third coming of domain-driven design, because with AI, suddenly we have a new and super important medium for ubiquitous language. When you are talking to an AI model, well, you are using human language. You're using ubiquitous language to define the functionalities. Now, if you are able to make that language precise, if you can avoid ambiguities by using bounded context, guess what? Your interactions with AI are going to be way, way more fruitful, at least in my experience. In my experience, because again, if the problem with natural language is that we have programming language which is like super precise. If you read it, there is only one way to follow it. Human language, you have policy. Well, what policy is, go figure, depends on the context. And if you use that word in conversation with AI, unless you're using a tool that will identify ambiguities and ask you about them, it will just make an assumption, code that assumption in, and yeah, guess what? When that component will need to be evolved in the future, if it will need to be evolved in the future, well, it might be that that assumption will be counterproductive. So that's right now what I think the role of domain-driven design in the brand new AI-driven world. But at the same time, even earlier than microservices, I said that modularity is about designing system in a way that is going to support implementation of your future needs. With AI, maybe in 2 years, I don't know, we won't need to change systems. We'll just rewrite them from scratch, and that's it. Like, hey, you have this code base, identify its functional requirements. Here are some new functional requirements. Make sure the old database works, and re-implement everything from scratch, and it will work. If that happens, well, we are in a problem. Let's be honest. We have a problem. So yeah, I hope that the future will take us towards the first direction where domain-driven design will be even more popular, because again, ubiquitous language models is way important today than it was 10 years ago.
Yeah, I really hope as well that is the direction of travel, to be honest. But obviously, we will adapt, as human beings are extremely good on adapting themselves. So I strongly believe that no matter what will be the evolution of software development, we will find our niche and our way to survive or potentially change job. That is nothing wrong with that. So that said, it's very interesting what you are framing domain-driven design with AI. It's exactly my same thought. I believe that is even more important than before, because now instead of writing code, we are writing, let's say, concepts. And obviously, in a decentralized fashion, developers, if I think about back in days, my time, I was extremely good on the area that I was basically developing or responsible for. But I struggle a bit to have the whole context of the organization wide. So understanding, okay, so this feature is coming up in 3 months. And I need to think about how this will impact my area. But majority of the time, I cannot say I was selfish, thinking about only my part of the system. But that is what I was paid for. This was the area that I was working on. Very often, taking a step back, especially when you need to deliver feature, you are under pressure, might be complicated and cumbersome. So I believe this new world where almost coding becomes a commodity. It free up time to developers in order to look more holistically on the system, interaction with the system, thinking about the boundaries, thinking about how domain-driven design works, and applying it inside their part of the system or multiple part of the system, because obviously it depends from your seniority and the type of role that you have. But I believe that will become in the AI era even more relevant, as you said, because it's something that I think that it provides a structure that currently is very fluid. If you think about context engineering, spec-driven development, is more okay. So let me write my requirements and that's it. While on the other side, we have some directions and some mechanisms that help us to say, okay, so first I need to identify the ubiquitous language. When I say user in this domain, it means that. When I use a user in that domain, it means something else, because I'm interested on different attributes of the same concept. I think that is extremely important and something that I hope that will democratize even further in the future, as you suggested. So now I wonder, if you had the chance to try some AI tools for, let's say, playing with architectures and see what would be the outcome out of that. I made some experiments, but I would like first to hear your thought and experience on that.
Yeah, of course. Of course, I invested quite some time in it. Yeah. Um, I'm not sure I have finished already. So all the results I'm getting so far still need to be proven. And what I can share is um, I tried teaching domain-driven design, like proper domain-driven design, to an LLM, and it was able to design technical stuff, aggregates, domain events, entities, value objects. Once you really explain what an aggregate is and not what people on Stack Overflow say, you will get way better results. So again, that confirms my point of view that strategic DDD is way more important nowadays, because if you make if you define that problem that you want AI to solve in a model that doesn't really reflect the business, then guess what? The implementation will steer from the business as well, from business needs. And again, I don't know what's going to happen in the future. If we will still need to modify code bases, then it's important. If AI will just rewrite everything from scratch, then I don't know. We'll see. We'll talk about that in a few years again.
Okay, let's avoid the catastrophic, but the catastrophic word or path where we won't see any more software and everything will be run by AI. I hope that we still have the possibility to have skin on the game, because I basically was part of my life, a good chunk of my life on software. So I really hope that we still have, in some shape or form, something to say to building software. But I wonder, as of today, let's not talk about the future, but as of today, what do you think is still, let's say, a human capability that could do better compared to AI when we talk about software architecture? So, what will be something that is uniquely human at the moment and the AI cannot take over?
Yeah, to answer that question, let's go back to the definition of modularity that I mentioned in the beginning. So, a modular system is the one that makes future changes easy. That's the goal of modular design. You decompose a system into components such a way that reasonable future changes will be focused on only one of those components. If you are there, you have modular amazing system. You have a change, only one of the components is affected by that change. That's great. The thing is, the hard thing is about that the definition is the word that I mentioned quickly, and I haven't spent much attention on it, and that's reasonable. Because you cannot design a system that will withstand any change. If you have I don't know, a CRM system, well, suddenly you want aliens as your customers. Is that reasonable change? Who knows? Because maybe aliens have different models for representing them in the system, and it will cause you to rewrite the majority of the models. Well, is that change reasonable? Probably not. So we people, let's say that we are working on a system and we're building that system for a business. We have the business goals in minds. And using that business context, we can, at this time, we can identify what those reasonable change vectors are. We know who the competitors are of that system. We know what they're doing differently. Maybe they're doing something better, and in the future we'll catch up. We'll do it in the same way. We'll just copy. Or maybe we know that that part of the system is our competitive advantage, and others will try to copy it. So it will change. So we have to design it in such a way that you will be able to change it as fast as possible because your business depends on it. So identifying what those reasonable changes that you might need in the future to design a modular system, that prerequisite to modular design, I think at this point it's our main strength, because AI doesn't know. All it knows is, okay, we have that data that the model was trained on. Let's see what is the average, what the average company needs. And that token will have the highest probability, and that's going to be the output. But your company, when you are designing your competitive advantage, you don't want to be average. You want to be way above the average. So that's the context that at this point of time is unique to people. We know that, so we can use that to to design modular solutions.
Absolutely. I really like how you frame it. Therefore, based on what you said, I don't know if you have heard few companies nowadays are hiring product engineers more than software engineers. That I found, let's say, very interesting, because those companies embrace AI. I cannot say fully, but obviously they have a good chunk of their workflow with AI. And to be honest with you, I like this distinction where we start to look into more. Okay, it's not enough anymore thinking about the software part. You need to think more about product. You need to think about the business side. And if you start to layer up the engineering side with the business side, then I think you are a very well-rounded individual inside a team, that when you have, let's say, multiple of them, they can become, let's say, the right people that boost the approach for a company. So do you like this new idea of product engineering, or what are your thoughts about that?
I'll be honest with you, I don't like the title because of negative connotations I have. Usually, product people that have software engineering backgrounds are the ones that bring you ERD diagrams to work with, and those are the business requirements. But those are my traumas from the past. Anyway, going back to the monkey book, the very first page, I quoted the question I get asked at almost each and every DDD training I did in the past. So you are talking about business. Do we really need it? We want to write software. We don't want to run businesses. Why do we need to learn about that? And on that page, I give the explanation why it's important. And today, it's way, way more important because, again, you're looking at a code base. Let's say, oh, you know what? Before the code base, you have a functionality that you need to implement. I think it's safe to say even somewhat complicated functionality, if you describe it and you throw it at cloud code, it will implement it in a way that it will work. It will work according to what you just defined. Things that you missed in your definitions, there will be used for making implicit assumptions, whatever. Bottom line, it will work. So working code is not a challenge anymore. The challenge is code that not just works, but serves the business long term. And for that, it's so important to have that product-oriented frame of mind as a software engineer. To be honest, I'm not sold on product engineer title. For me, a software engineer needs that. To design software, you need that product thinking. You need to produce code that not just works, but serves the business long term. For that, without understanding the business, it's simply not possible.
Thanks for sharing your point of view. I like that. let's talk about your books for a second. So I wonder, I wrote a few of them as well, and I know that sometimes when you publish, a few months later, you start to think, oh, but I should have added that part that in reality I didn't, either because I didn't think about during the time I was writing the chapter, or because I need to rush in order to deliver the chapter, or one of the two, basically. So I wonder if there is anything missing on the Learning Domain-Driven Design book that today you would like to add as addendum, maybe.
Unfortunately, of course. So I really love doing Q&A sessions for book clubs. If I hear on LinkedIn or some social media that there is a book club reading my book, I always offer them, hey, once you finish reading it, let's do a Q&A session, 1 hour, 2 hours, whatever questions you have, I want to hear them. I'm interested to know like what lands okay and what are the topics that would need more attention. And consistently, the one topic that would require more attention is subdomains and how to identify them. And that's no doubt the hardest part of domain-driven design. It's the hardest part of DDD for many reasons. Not bounded context that people are afraid of, not aggregates, not ubiquitous language that for ESL speakers like me to spell it on the first time, it's like mission impossible. Now, subdomains, that's the hardest part of DDD, and I would at least add another chapter about it. That's one thing. The second thing, in the event storming chapter, I followed let's say, traditional way of describing process mapping, where you have like a limited area of the like a limited business process you want to explore, but you want to explore it all the way down to the finest details, from domain events to read models, aggregates, and then in the end we have bounded contexts. And I don't agree with that anymore, because bounded contexts, they're a function of multiple things. First of all, models. Of course, if you have conflicting models, that calls for introducing multiple bounded contexts. However, I've always been against, introducing bounded contexts for the sake of we want to be microservices or something like that. Let's say you have a fairly large business domain, but there are not many conflicting models. If that's a startup company, well, identify conflicting models. That's the minimum number of bounded contexts you need, and stay there. Why? Because it will be easier to change a wide bounded context than to decompose it prematurely and then start chasing your own tail when you need to change something in that design. So when would you decompose it? Well, that's the second driver for bounded context, and that's organizational constraints. If suddenly you have more teams introduced to the company, then you'll need to take that wide bounded context and draw a line somewhere in the middle of it so that you can assign a bounded context to each team. Again, only one team should work on a bounded context. That's the definition. And in that chapter, in process mapping, the last step is bounded context, and it only reflects the models. It doesn't reflect organizational drivers. So right now, I would rather say that it gives you a stronger hint of subdomains rather than bounded contexts.
Yeah, I tend to agree on your let's say definition here. Also because when I do event storming with companies, I start to talk about. I tend to do let's say big picture event storming mainly because that is the level of engagement that usually they're asking us. The interesting part is that you can identify some interesting subdomains But then there on the granularity side, I defer to the organization itself, because the challenge is, as you said, the organization structure, can it be changed, or we need to tweak the architecture towards the organization that must remain as it is? That usually is might be a challenge overall in the long term. But also there are some details, obviously, that they don't surface in the limited time that I have. That usually is a couple of days for running that, and therefore, worst case scenario, I will run another session dedicated to a specific subdomains to drill down even further that part. So definitely, I align with your vision on that. So you did a ton of stuff for the community, writing books, talks. Really, you are extremely visible in the software architecture community. So I wonder what's next. So what is your activities plan for 2026 and onwards?
There's tradition, or should I say, a pattern. Whenever I announce my plans, nothing happens. No, something happens, but the opposite, something that prevents me from doing that. So I'll just say that when the coupling book came out, it was a PTSD for me, like a full-blown PTSD. I said, that's it. I'm not writing anymore. I will just send voice messages, and that's it. Not even emails. I'm not going to write. I'm done with writing. Well, I'll just say that I rethink that decision. I had to rethink it. That's all I'm going to say.
That's fine. We will follow you on social media, and hopefully we will see new insights from you, because definitely your experience is extremely valuable for the community. Vlad, it was an absolute pleasure spending this hour with you, and I love what you shared. It's very pragmatic and also very well thought and described. So I think everyone will gain some nuggets of wisdom from you during this episode. So thank you very much for that.
Thank you so much, Luca. I really love the conversation and love the questions.
Perfect. So thank you everyone for listening to us. And I will invite you to follow us on the different channels, Spotify, YouTube, etc., where you can find these podcast, and more importantly, subscribe to the Dear Architects newsletter so you won't lose any other issue. And more importantly, you are going to discover what Vlad is going to do, because I usually share all the people that I'm interviewing in this podcast, resources and new things that are working on. So definitely follow us, and see you in the next episode of Dear Architects podcast. A quick thank you again to IcePanel for sponsoring this episode. If you're looking for a better way to map complex systems, check them out at icepanel.io/Luca. And remember, stay chill,